We wouldn't be here if it wasn't for the sun, our star, and like any other star, it probably formed by the condensation of gases in space. Hydrogen and helium are the first two elements of the periodic table. It's not a coincidence that they are also the two most abundant elements in the universe. They constitute most of the matter of the giant interstellar clouds that we know as nebulae. But a nebula doesn't regularly form stars on its own, because, like the gases on the Earth, it expands as the amount of matter increases, preventing it from reaching enough density to suffer a gravitational collapse. The density needed to overcome this problem is described by the Jones-Moss. So, to produce stars, these molecular clouds need some sort of disruption, and this can happen with supernovae occurring near the cloud, or due to collisions with other clouds. Stars work by the process of nuclear fusion. This is how they generate their heat. First, the temperature is raised by the compression caused by the gravitational collapse. Then, when they reach enough heat to fuse hydrogen into helium, they depend on the weak force to turn some protons into neutrons. These particles collide and are kept together by the strong force, creating helium. This process continues with other elements until the star dies because it can't maintain nuclear fusion any longer. When enough density is reached, the gravity starts to condensate the gases and eventually something starts to form in the middle, a protostar. What you see here is a representation of that phenomenon, the formation of a star. If the protostar is too small, it won't be able to produce enough heat to fuse hydrogen into helium, and with no nuclear fusion, there is no star, so it would become a brown dwarf. On the other hand, if the protostar is able to sustain nuclear fusion, it will move on to the next period of its life, the main sequence.